talked about single replacement reactions, we're going to be talking about double replacement reactions. Okay, so what happens in a double replacement reaction, and we've already talked about this, but let's review. You're going to be switching partners. So specifically, you're going to start off with A and B together. You've got a compound, and C and D, and they're going to react together, and then you're going to end up switching partners. So A and D are going to form a compound together, and it's going to be in that order because A will be positively charged and D will be negatively charged. And remember, your cation always goes before your anion. And your other product is going to be C and B, again, because your cation goes before your anion. So let's look at an example. So this problem asks me to write the net ionic reaction for each of the following. So I'm going to first write out my double replacement reaction, and then I'm going to explain what net ionic reactions are. Okay? So I've got copper 2 nitrate. Okay? So I'm going to write this out. So I've got copper. It has a 2+ charge, and nitrate, which has a 1- charge. So that's going to be CuNO3 Okay, across my charges to create that compound. And my other product is going to be iron chloride. Well, iron has a 3+ charge. Chlorine or chloride has a 1- charge, so it would be FeCl3. So those are my two reactants. Now I've got to write my products. So copper and chlorine are going to form a brand new compound. In order to write this, I need to recross my charges. Well, copper has a 2+ charge. Chlorine has a 1- charge, so this is going to be CuCl2 because I crossed my charges again. My other product will be iron with nitrate. Iron's 3+, nitrate is 1-, so this is going to be FeNO3. Okay. Last thing I have to do really quickly before I move on is I have to balance. So right now I've got 2 nitrates here and 3 nitrates here. So to make 2 and 3 equal to each other, I'm going to put a 2 in front here to make that 6, and I'm going to put a 3 here to make that 6. Okay? Then I now have 3 coppers here, so I'm going to put a 3 here. And I've got 2 irons there, so I'm going to put a 2 there. And I should be balanced because notice I've got 6 chlorines now, 6 chlorines. I'm balanced. So that is my complete double replacement reaction. That is a full reaction right there. Then I could ask for your full ionic reaction. So full ionic means I'm going to take everything here that will dissolve and I'm going to break it apart. So if it'll dissolve in water, I'm going to actually have it break apart. Well, that leads to the question, how do I know if it's going to break apart? Well, I'm going to use my solubility rules. So if you look, for example, copper nitrate, will it dissolve? Will I need to break it up? Well, if you look, notice most of these rules are for the anions, so you've got all of these anions. It does have some rules up here for some cations. Just read them carefully. So here, under this table right here, it says compounds containing the following ions are mostly soluble. We're going to assume they're just soluble. So if you have NO3 in your compound, then it will always be soluble because there are no exceptions. Okay, so notice I'm not looking for copper. You tend to look for your anion. So I found nitrate here, saw that there were not any exceptions. So that tells me that this is going to be soluble. So it's going to break apart. So I'll break it apart in just one second. Iron chloride. Okay, for chloride here, I found that. Then it says it's soluble except when any of these ions pairs with silver, mercury, or lead. Well, iron is not silver, mercury, or lead, which means it's going to be soluble as well. For copper chloride, I'm going to found my chloride right there. It says when any of these ions pairs with silver, mercury, or lead, it's going to be insoluble. Otherwise, it's going to be soluble. Well, in this case, this is going to be soluble because it's not an exception. And then finally, for nitrates, nitrates are always soluble. Therefore, that's going to be soluble. So here is what you would write for your full ionic. I have to break everything apart because nothing is insoluble. Okay? So let's actually write this out. I've got copper ions. So I have 3 copper ions. I've got to put copper in the charge of copper, which is 2+. What else do I have? Well, I have 2 nitrate ions. So 2NO3 minus. Okay, notice I put the 2 in front and I didn't leave it behind. You got to put it in front to show that you have 2 nitrate ions. What else do you have? Well, I have 2 iron ions, and they have a 3+ charge. And I have 2 times 3, I've got 6 chloride ions, Cl minus. Okay, so that's my reactants. For my products, I've got 3 copper ions, and all of these are breaking up because they're all soluble. I've got 6 chloride ions. I've got 2 iron ions, and it has a 3+ charge. And I'm going to write right below here because I ran out of space. I've got 6 nitrate ions. Now, I noticed as I'm writing this, I made one mistake, and maybe you guys caught me on it. I don't have only 2 nitrates here, like I wrote right there. Notice I've also got a 3 in front, so it's 3 times 2, which gives me 6. So if you notice you've got different amounts of one polyatomic ion or one ion on either side, you did something wrong. Now, to write the net ionic, anything that is identical on both sides, I'm going to eliminate. So notice my coppers are the exact same. My nitrates are the exact same. My irons are the exact same. My chloride ions are the exact same. So the question you're saying is, okay, what is my net ionic equation? What happens in my net ionic reaction? There is no reaction because nothing is formed because everything cancels out in this example. Okay? Will that always happen? Not at all. So let's look at an example of when that isn't actually the case. Barium acetate, so I'm going to write out my formula. So I'm going to write the full ionic. So I'm going to write the full reaction here, the double replacement reaction. So I've got barium acetate. So barium has a 2+ charge. Acetate, C2H3O2, has a 1- charge. So I'm going to cross charges, C2H3O2. And I'm going to put a subscript 2. That reacts with ammonium sulfate. Ammonium is NH4. It has a +1 charge. Sulfate, SO4, has a 2- charge, so +1, -2. So I'm going to put parentheses 2 there. That produces, okay, now I have to switch partners. So barium is going to form a partner with SO4 and NH4 with acetate. So barium has a 2+ charge, sulfate has a 2- charge. So it would be Ba2SO4 Remember that they would simplify to just BaSO4. And I've got ammonium, which has a +1 charge, and acetate, which has a +1 charge. So when you cross your charges, they just stay as they are. So NH4 and C2H3O2. Now I need to balance. I see I have 2 acetates here, so I'm going to put a 2 in front there. Remember, you can't split it up. You got to put the 2 in front. And I got 2 ammoniums, and I'm good. Okay, so let's now write your full ionic. So we're going to break apart anything that is soluble. So I look at acetate. I'm going to find acetate on my table. Acetate is soluble, and there are no exceptions. So I'm going to put that it is soluble. It's going to dissolve. Ammonium sulfate. Okay, so I'm going to look up sulfate here. Okay, when sulfate pairs with SRBA, PB, or Ca, the compound is insoluble. Well, that's not the case. And the other thing for you to know, if you look up here, ammonium's actually on the table too. Lithium, sodium, potassium, and ammonium are always going to be soluble. So this is going to be soluble. Okay, barium sulfate. For sulfates, they are soluble except when they're paired with strontium, barium. Aha! So now this is my first example of this being insoluble. Okay? Then I look at this guy. Acetate, again, if you look at it, is always soluble. Okay, so I'm going to break apart anything that is soluble, and I'm going to leave alone anything that is insoluble. So barium, acetate is going to break apart into barium ions. And remember, you put the 2 in front, 2 acetate ions. What else? Well, I have 2 ammonium ions, because that's soluble as well. and sulfate, SO4 2-. Okay? That produces, well, this is insoluble, so I'm going to leave it alone. I'm not going to break it apart. And this is soluble, so I'm going to break it apart. 2 ammonium ions and 2 acetate ions. Okay. Now I'm going to cross out anything that remains the same on both sides. Notice barium ions are here, but it's part of a compound here, so that doesn't stay the same. Acetate and acetate do. They're the exact same. Ammonium and ammonium do. So my net ionic equation or reaction is going to be barium ions reacting with sulfate ions to produce barium sulfate. Okay, so those are net ionic equations, and you're going to get a lot of practice with that in class. Now let's look at just regular double replacement reactions, but this is going to be a little bit different. It's basically the exact same thing. It's just a tiny bit different. Okay, so I'm going to write this out again. I've got calcium hydroxide. So calcium has a 2+ charge. Hydroxide has a 1- charge, so 2 and 1. So I'm going to cross my charges, and I'll put the 2 there. That reacts with hydrogen bromide or hydrobromic acid, okay, HBr. Remember, you're going to combine, you're going to switch partners. So calcium with bromine. So calcium has a 2+ charge. Bromine has a 1- charge, so it's going to become CaBr2. Plus, here's the only new part. You've got H and OH. Hydrogen has a +1 charge. Hydroxide has a -1 charge. That would give you, and I'm going to just write it up above because this is not what I want you to write. This is HOH. If I were to combine them, well, that's actually just H2O. So notice calcium hydroxide, that's a base. This is an acid. So when you combine a base and an acid together, you get a salt, an ionic compound, and water. Now, I'm not balanced yet. I see I have 2 Brs here, so I'm going to put a 2 here. Now I've got 2 hydrogens here, 2 hydrogens here, so I'm going to put a 2 in front there, and now I am finally balanced.